Today we are going to see about the photoelectric effect. To prove the photoelectric effect, there are so many experiments conducted by the scientists Hertz, Hallwachs and Lenard. Today we are going to see about the Hertz, Hallwachs and Lenard's observation. So by means of conducting so many experiments, they have proved the photoelectric effect. First we are going to see about the Hertz observation. In the case of Hertz observation, Maxwell's theory of electromagnetism predicted the existence of the electromagnetic waves and concluded that the light waves are electromagnetic waves. But they have tried to generate and detect the electromagnetic waves through various experiments. In the year of 1887, Hertz was successful in generating and detecting the electromagnetic wave with a high voltage induction coil causing a spark discharge between the electrodes. But already we have seen it in the unit of 5 in the first volume. When a spark is observed, the charges will oscillate back and forth and they are moving very fastly and producing the electromagnetic waves. The electromagnetic waves thus produced be just detected by a detector. That is nothing but a copper wire which is just be in a bended form. So the detection is successful. They have not known that what is the real reason for producing the spark. Then he analyzed that. He tried so many times to increase the spark value. Then he found that by applying high electromagnetic waves be just be produced and a spark is just produced by just introducing a ultraviolet rays. So when the ultraviolet rays are just falling on the surface, the spark be more. So by seeing the spark itself, he tried to improvise the spark which is produced. The important factor just by following the ultraviolet light itself, it produces a spark. The reason for this behavior of the spark is not known at the time. Then the later only the scientists just predicted that the spark value just be increased because of just the photoelectric effect. Whenever the ultraviolet light is incident on the metallic sphere, the electrons on the outer surface are emitted, which cause the spark in the vigorous manner. It is very interesting to note that actually the same experiment of conducted by the Hertz proved the wave theory as well as for the particle theory. Then the next experiment be Hallwachs observation. In the year of 1888, Hallwach, a German physicist, confirmed that the strange behavior of the spark is just due to the action of the ultraviolet ray that is falling on the surface. So a clean circular plate has been just taken out and it is mounted on a insulated stand. Then which is attached to a gold leaf electroscope by means of a wire. When the uncharged zinc plate is irradiated by ultraviolet radiation, then here in the case of it becomes a positive charge matter. So the two, this is the gold leaf electroscope, one leaf, another leaf. So they are experiencing a force of repulsion and the leaves are just departed apart. See, this is the zinc plate. The zinc plate is just first uncharged, neutral plate. No positive charges or negative charges present there. They are in combined state. Then ultraviolet radiations are just allowed to pass on the zinc plate which is in the neutral condition. So due to the presence of the ultraviolet radiation, it becomes positively charged. So the two leaves are just becoming positively charged and experiencing a force of repulsion. That is the arrow mark shows outwards. So it gives that the leaves are just experiencing a force of repulsion. So this is just represented by the figure A. Then in the figure B, the ultraviolet radiations are just falling on the surface of a already negatively charged plate. This is neutral plate, zinc plate. This is a negatively charged zinc plate. So what happened means, here the negative charges are leaked through the thing and the force of attraction just taken place between the two leaves. So it comes closer. then that is represented by the figure B. Then in the figure of C, here the zinc plate is positively charged. First the zinc plate is neutral, the second one is the zinc plate is negatively charged, and now the zinc plate is positively charged. Then the ultraviolet radiation are allowed to pass on the zinc which is already positively charged. So that what happened, the positive charges are it becomes more positively charged and experiencing a force of repulsion. So the leaves are just moving apart. So here it shows that the negatively charged zinc plate is exposed to ultraviolet light, the leaves comes closer. If the plate is positively charged, it becomes more positive and force of attraction towards the leaves, so it comes closer. And when it is the ultraviolet radiations are just passing through your zinc plate already positively charged, then the leaves are just moving outwards. The next one is Lenard's observation. In the year of 1902, the scientist Lenard studied that the electron emission phenomena in a detailed manner. His simple experimental setup is just given here. C is a cathode ray tube, A is a anode, and here they are connected to a battery. In addition to that one, a galvanometer is present in the circuit. First, the ultraviolet radiation is allowed to pass on the, just falling on the surface of the cathode C. So the electrons are just emitted, the electrons are just attracted towards the anode, so the galvanometer shows a deflection. So galvanometer is an instrument which is used to detect the presence of the electric current. So whenever electrons are just emitted, they are just producing a current, and that current is just measured through a galvanometer. Then afterwards, the ultraviolet radiation is just allowed to pass on the, falling on the surface of the anode. This time there is no current flow through the circuit, so the galvanometer shows no deflection at all. So it shows that the presence of the ultraviolet radiation when they are falling on the surface of your cathode, already a negative plate, it produces it liberates the electrons and they are attracted by the anode and producing a current through the circuit. When the electrons are just falling on the surface and producing the current, it shows that it is just measured by the galvanometer. But when the ultraviolet radiation is falling on the surface of the anode, there is no more deflection. It means no current is just flowing through the circuit. Next, we are going to see about the photoelectric effect. The ejection of electrons from a metal plate when illuminated by light or by means of any other electromagnetic radiation is known as photoelectric effect. Here, the electromagnetic radiation has been just chosen in such a way for having a suitable wavelength. That means for a particular frequency is called the photoelectric effect. These electrons are not different from ordinary electrons, but here it is just produced due to the illumination by some means of light. So these electrons are known as photoelectrons, and the effect which is just cast is known as photoelectric effect. So the photoelectrons are flowing through your metal or by means of any media and producing the photoelectric current or photocurrent. So the metals like cadmium, zinc, magnesium, etc. show the photoelectric emission when the ultraviolet radiation is just falling on the surface. But in the case of alkali metals, lithium, sodium, cesium, they are responding to a higher extent of known values of larger wavelengths of radiation, like even the visible light. The materials which eject the photoelectrons upon irradiation of the electromagnetic waves of suitable wavelength just known as, in the case of process, the materials are just known as photosensitive materials.